Here's the problem. The problem says the cosine of theta is negative root 3 over 2. And the theta is between 540 and 630. But when you subtract 360 from each of those, you get it's in the third quadrant between 180 and 270. Everybody understands why that is?
Yeah.
And they want us to find the sine of 2 theta. So the sine of 2 theta formula is 2 cosine of theta, sine of theta. So since the cosine of theta is negative root 3 over 2, we know it's adjacent. So I put the negative root 3 on the adjacent and the 2 on the hypotenuse. Well, for this formula, I need the cosine of theta, which I already have, but I also need the sine of theta. So I'm going to have to find that third side. Kind of scope it out, because sometimes you don't have to look for something else, okay? And sometimes you do, so don't waste your time. So we have x squared plus root 3 squared equals 4, which is 2 squared. X squared plus 3 equals 4. X squared equals 1. X equals 1. The sine of theta is going to be negative 1/2. All right, so now we have 2 times cosine of theta, which is negative root 3 over 2, times sine of theta, which is negative 1/2, and that's going to be 2 root 3 over 4, which is root 3 over 2, positive. So when we check it, we do second cosine of negative root 3, put a parenthesis there, divided by 2, and that's going to be 150. But we know it's not 150 because 150 is right here. So 150 is 30 away from 180, so we have to add 30 to 180, and that gives us 210. So theta equals 210. If theta is 210, what is 2 theta?
Times 2, or 420.
420. So they want us to tell them what the sine of 420 is. That's 2 theta. So we just do sine of 420, and we get 0.8660254038. Oh, but I got this mess, which is the format I wanted in. So it's square root of 3 divided by 2. Oh my gosh, it's the same ugly decimal.
Oh wow, we got it right.
Okay, so they tell me the sine, and they want me to find the cosine of 2 theta. So I look at my 3 choices for cosine of 2 theta, and since I already have the sine, I'm going to pick the last one. And for some reason, whoever invented the squaring, these formulas, when they have sine squared of theta, that really means sine of theta squared. But they put it that way, and I really don't know why. But that's how they put it. So whenever you see cosine squared of theta or sine squared of theta, it's sine of theta squared, okay? So now we put this in our formula. 1 minus 2 times negative 15 over 17 squared. And we put that in our calculator. So here we go. We have it on the 4th quadrant. Who has a sine of negative 15 over 17? Just do second sine of negative 15 over 17. And this one's going to give you an answer where you want it, I believe. And you get negative 61.92, right?
Oh gosh.
When you add 360 to it, you get 298. So theta equals 298.07. Well, what's 2 theta? Times 2 is 596.
Oh my gosh, I don't like this.
0.14, and we need to find the cosine of 2 theta, so cosine of second answer, and we get negative 0.557093 0.4256. And then we put that in the calculator, and we say a little prayer. And oh my gosh, it's the same exact number.
Wait, how'd you get that big?
So in this case, when I did second sine of -15/17, it gave me an angle in the fourth quadrant. I didn't have to move it. You see how third quadrant is always a pain? Fourth quadrant is not always a pain, unless its cosine is positive, and then it'll give you something in the first quadrant. So we didn't have to move the angle, then we doubled it, and then we found the cosine of the double angle, and we got this decimal, and then we put this in, and it's the same ugly decimal.